Good morning, everyone. I am Mrs.P.Hameetha Begam, Assistant Professor of Mathematics, A.D.M College for Women, Autonomous, Nagapattinam. Now, I am going to discuss about the topic sequences and series. Sequences and series was first introduced by a German mathematician called Friedrich Gauss, who lived during 1777 to 1855. Sequences and series forms the fundamental and basic part of mathematics, and it has many useful applications in statistics, physics, finance, etc. Before entering into the concrete definition of sequences, let us see well-known sequences. First of all, sequences of natural numbers, which is 1, 2, 3, 4, etc. Here, each number is followed by a successive number, its successor. And in sequence of odd numbers, 3, 5, 7, 9, etc. It also follows a rule such that 2n plus 1, where n belongs to the natural numbers, and the sequence of even numbers 2, 4, 6, 8, etc. So, in general, sequence is a list of numbers which follows a certain rule, arithmetic sequence. And also, we have studied arithmetic sequences, geometric sequence, and Fibonacci sequence. In arithmetic sequence, the difference between any two numbers or any two terms is a common difference D, and the sequence is A plus G, A plus 2D, A plus 3D, etc. We studied in the earlier classes itself this arithmetic sequences and also the geometric sequence. In geometric sequence, each term is found by multiplying the previous term by a constant term. So the series is, the sequence is AR square, etc. And the well-known famous sequence called Fibonacci sequence is a sequence in which each term is found by adding the previous two terms, where xn is equal to xn minus 1 plus xn minus 2, and the sequence is 0, 1, 1, 2, 3, 5, etc. Next, let us see the concrete example of the sequence. Let f from n to r, n is a set of natural numbers and r is a set of real numbers, be a function defined by f of n is equal to an. Then the sequence is a1, a2, a3, etc., an, etc. And this sequence is denoted by bracket an. Here, an is called the nth term of the sequence. The range of the function f is a subset of R, which is called the range of the sequence. The terms of the sequence need not be distinct, and the range may be finite or infinite. Some examples. Let f from n to r, which is defined by f of n is equal to n. Here, if we allot 1, 2, 3, etc. for the values instead of n, we get the sequence 1, 2, 3, etc., n, etc. Here it is a infinite sequence. Another example, f from n to r, which is defined by f of n is equal to minus 1 the whole power n, which determines the sequence minus 1, 1, minus 1, etc. If we allot 1, 2, 3, etc. for n, the first element is minus 1, the second element is positive 1, and the third element again negative 1, fourth element positive 1, etc. But here the range is minus 1 and 1, so which is finite. Another example, let f from n to r given by f of n is equal to 1. Here the range contains only 1. None other number comes under the range and the sequence is 1, 1, 1, etc. So this type of sequence is called a constant sequence. Next let us see the limit of a sequence. Limit means in a sequence after a stage, this limit approaches a fixed number called the limit. The graphical representation of that limit is the sequence. It goes on and it approaches nearly 0 in this sequence. So the concrete definition of the limit: a sequence an is said to tend to a limit L for a given positive integer n epsilon, however it may be small, can always find an integer n such that modulus an minus L, which is less than epsilon, for all n greater than or equal to n. Here L is the limit of the sequence and it is expressed as limit n tends to infinity an is equal to n, or the sequence an converges to n. Also, the value modulus an minus L less than epsilon can also be represented as interval such as L minus epsilon less than an less than L plus epsilon. Let us see some examples for finding the limit of the sequences. Consider the sequence an where an is equal to 1 divided by n. If we give values for n as 1, 2, 3, 4, etc., the sequence find is 1, 1 by 2, 1 by 3, 1 by 4, etc., 1 by n, etc. And how to find the limit of the sequence? Previously we have seen the definition of the sequence, and from that let us find the limit of this sequence. The nth term, we have to find the nth term of the sequence. Here the nth term is 1 by n. So applying the definition, limit n tends to infinity nth term, that is 1 by n. So here 1 by n, when applying n tends to infinity, the value approaches 0. Therefore, the limit of this sequence is 0. Another example in finding the limit of the sequence. So find the limit of the sequence n minus 1 divided by 2n plus 3. Here give values for n as 1, 2, 3, etc. So the first element is 1 minus 1, 0, 0 by anything is 0. In the second element, if we give n is equal to 2, so the second element is 2 minus 1, 1 in the numerator, and 2 plus 2 into 2, 4, 4 plus 3, 7. So 1 divided by 7. And again apply the value 3 for n. So we etc. and etc. we get the sequence 0, 1 by 7, 2 by 9, etc. n minus 1, 2n divided by 2n plus 3, etc. So here the nth term is n minus 1 divided by 2n plus 3. Now limit n tends to infinity, nth term, that is n minus 1 divided by 2n plus 3 is equal to limit n tends to infinity, and if we apply infinity we get we shall not get the finite value. So we can take the value n as common and we can bring the n in the denominator. Correct. So taking n as common in both the numerators and the denominator, we get the term n into 1 minus 1 divided by n in the numerator and n into 2 minus 3 by n in the denominator, and both the n gets cancelled in the numerator and the denominator, and the remaining fraction is 1 minus 1 by n divided by 2 plus 3 by n. When limit n tends to infinity in this term, we get the answer 1 divided by 2. Therefore, the limit of the sequence is 1 by 2. So, like this, applying the definition, we can find the limit of given sequences. Next, let us see about the convergent sequences. There are 3 types of sequences known as convergent sequence, divergent sequence and oscillating sequence. Now, let us see convergent sequence. A sequence an which tends to a finite limit is called a convergent sequence. Examples, the sequence is 1 by n. Already we have seen 1 by n and we have found the limit also. The limit of this sequence 1 by n is 0 in the previous example, and therefore it has a finite limit, and this sequence is called a convergent sequence. Also n plus 1 divided by n and the n minus 1 divided by 2n plus 3 sequence are also convergent sequences. Next, divergent sequence. A sequence which tends to an infinite limit is called a divergent sequence. Examples, the sequences n, n square, 2n are all divergent sequences. Oscillating sequence. A sequence, previously we have seen a sequence which converges to finite limit, it is called convergent, and infinite limit means it is divergent. Here this sequence neither converges and nor diverges. So this sequence which neither converges or diverges is called an oscillating sequence. Example, the sequence is minus 1 whole power n. Here the sequence determined is minus 1 plus 1 minus 1 plus 1. So the range is minus 1 and plus 1. So it neither converges and nor diverges, but it has 2 values. So it is an oscillating sequences. And also minus 1 the whole power n plus 1 is also an example of an oscillating sequence. Let us see some of the statement of the theorems regarding sequences. Sequence an cannot converge to 2 distinct limits. So from this theorem we are clear about that a sequence has only one limit. And second theorem, if an and bn are convergent sequences. Convergent sequences means it has a finite limit. Then the sequence an plus or minus bn is also a convergent sequence, and it converges to the value a plus or minus b. And one more theorem, if sequence an is a convergent sequence and bn is a divergent sequence, then the sequence an plus bn is divergent. If an and bn are both divergent sequences, then the difference of this sequence an minus bn may be divergent or convergent or oscillate. And similarly, we are having some more theorems in product and division. That is, if sequence an converges to a and sequence bn converges to b, then sequence an into bn converges to ab, and if sequence an converges to a and sequence bn converges to b, which is not equal to 0, then sequence an divided by sequence an divided by bn converges to a divided by b. It's an important theorem on limits, that is Cauchy's first theorem on limits. If a1, a2, a3, etc., an, etc. denote a sequence of numbers such that limit n tends to infinity an exists and is equal to L. If such a sequence exists means, then limit n tends to infinity, the average values of the n elements, first n elements, that is a1 plus a2 plus etc. an divided by n, it also exists and the value, the limit is equal to L. So this is a famous theorem on limits. There is a principle of convergence which is derived by Cauchy, that is Cauchy's general principle of convergence. It gives the necessary and sufficient condition for the existence of a limit of the sequence A_n. That is, if any positive integer epsilon has been chosen, however it may be small, there shall be a positive integer m such that modulus A_n minus A_m is less than epsilon for all n greater than or equal to m. In this module, we have seen the statements of the theorems only. In the next module, let us see the proof of the theorems. Thank you.